In the last of these mass spectrometry videos, what we're going to do is take a look at the mass spectrum of compounds, and how that will appear will depend on the method of ionisation used. Elements that we've just been looking at are always done by electron impact, but compounds could be done by either. So we're going to look at electron impact first. Remember, that's where we fire the high energy electrons and knock off an electron. And we can write an equation for the ionisation of methanol. We take that and we knock off an electron with our electron gun. It will become methanol plus an electron. Can you add up, using your periodic table, the MR of methanol? So you should have 1 carbon and 4 hydrogens and 1 oxygen. If you add that up, you will see that you should have the answer 32. So the compound weighs 32, or should. Here's our mass spectrum. So let's have a look at what came out of our machine when we put a compound in. Now, there's a lot going on, and students get confused with this, and it's like, oh, there's all these isotopes, 1, 2, 3, 4, 5, 6, 7, there's like 8 isotopes of methanol. No, you can't have isotopes of methanol. Methanol is a compound. The elements could have isotopes, but not the compound. Now, we know from our adding up that the MR is 32, and here's 32. So this peak here is the peak due to the whole compound, and we call that the molecular ion peak. It's the peak due to the whole molecule as an ion. In this case, our molecular ion was the whole of that CH3OH with the plus. The M over Z of this peak is equal to the MR of the compound. That's our molecular ion peak. These peaks here, so all these other peaks below the MR, all of these are fragment ion peaks. So what do we mean by that? Well, we put in our molecule, and inside the machine, because we're bombarding it with electrons and energy, the molecule falls apart. Elements can't fall apart. Elements are simple, but molecules can break apart, and when they break apart, we might get bits to do with the sections. So this one at 31 might have a lot due to loss of just one of the hydrogens. The peak at 15 is the mass of a C and 3 hydrogens. So if you imagine that part of the molecule fell off, this is just for a CH3 plus, a methyl group as an ion. This peak here could be due to the CH3O, but without the last H, that would weigh 1 less. And you can do this process. You will not be expected to identify large numbers of these peaks because we don't always know what some of them are. They're caused by rearrangements, bits sticking back together inside the machine. So we wouldn't want you to be labelling everything. If they ask you to label a peak, it will be an obvious one. The one thing they might ask you about is this tiny little blob at just at 33. How can you weigh more than the whole molecule? Well, this is called an isotopic peak. And we get isotopic peaks because carbon can also exist as carbon-13, and hydrogen can exist as deuterium, it's hydrogen with a mass number of 2, and those things would cause us to have a slightly higher mass, 1 higher. So we've explained that on our diagram, but we can write something down. The peak at 32 is due to our molecular ion, so it's the whole molecule as an ion. And the peak at 33 is our isotopic peak due to molecules containing carbon-13 or hydrogen-2, sometimes called deuterium. And why are the peaks below? So we had those ones below. Electron impact ionisation causes fragmentation. So this bombarding with high energy electrons causes fragmentation. So it causes our molecule to break up. So if you can imagine our CH3OH molecule as an ion, inside the machine might split up and we might get CH3O plus, or we had that CH3 plus, and this was at an M over Z of 15, and this was at an M over Z of 31. So these things might happen. We might fragment, break up. So what if we've used electrospray ionisation with our compound? Well, the key thing to learn about this is it does not cause fragmentation. So you will just get peaks due to the molecular ion and isotopes. You will not get lots of other information at the bottom of your spectrum. So we've got an example here of a rather large molecule. Can you add up the MR? So pause the video, get your calculator out and add up the MR. So we've got 12 carbons, 24 hydrogens and then 6 oxygens, and we're getting 264. Now because this is electrospray ionisation, what we're going to do is pick up a proton from our solvent, and so if we had 24, we've now got 25 hydrogens, and the thing has become positively charged. So here's our mass spectrum. We've got 2 peaks. The peak at 265 is our MH plus peak, so that's our molecular ion plus solvent peak, and our peak at 266 is our isotopic peak due to those isotopes of carbon 13 or hydrogen with a mass number of 2. So our peak at 265 is due to our C12H25O6 plus. And so if we wanted the MR, this the MR plus 1 is equal to the M over Z value. So actually the MR of this compound is not 265, it's 264 like we calculated at the top. And our peak at 266 is our isotopic peak due to carbon 13 or hydrogen 2. Why are there no peaks below? And that is because ESI, electrospray ionisation, does not cause fragmentation. So elements don't fragment because they can't. Compounds will fragment if you use EI, electron impact, but not if you use electrospray. Okay, so this is one more example for you to have a go at. See if you can work out what this might look like. So have a go yourself, see if you can work it out. So we should have added up the MR, 289, 11 carbons, 19 hydrogens, 3 nitrogens and 6 oxygens. And because we're doing electrospray, we're adding a proton through the tip of that hypodermic needle. We're adding a proton and we're going up to 20 hydrogens. So now we need to draw this on the spectrum. Now given that this bit weighs 289, but this bit will weigh 290, we need to draw a peak at 290 for our molecular ion plus 1, our MH plus. So 56, so about here, and that will be a nice big one. This will be our MH plus, which in this case is C11H20N3O6 plus. But we might see a very small peak next door. That is our isotopic peak at 1 further on. And remember that neither of these is at the mass of the actual molecule, they're both more. So see if you can compare the two types in terms of the ion that they produce, whether they have fragmentation or not, and what they're used for. So our first thing is that in electron impact we just get the molecule as a positive ion, and so the MR will be the mass to charge value for that molecular ion peak. And in electrospray we get MH plus, and so to get the MR we're going to go to that molecular ion peak, but we've got to subtract 1 to find the MR. Electron impact does cause fragmentation, but electrospray does not. And we're going to use electron impact for elements, and and small molecules where we can cope with the fragmentation because there's not going to be too much. But we'd use electrospray for larger molecules like proteins and polymers. So your biochemists are going to be using this a lot more. That's the end of our little section on time of flight.